Right, hello Year 11 and welcome to our first lesson of the week on crude oil and fuels, where today we're going to be focusing on crude oil and the process in which we can separate it to get really useful products from it. So I've gone through the specification. I'm going to come back to this slide right at the end. But these are the points that you have to know, or what is that they might examine you on. So you need to know how crude oil was formed, what crude oil is made up of, what an alkane is and the general formula for an alkane, the process of fractional distillation, which you do in Key Stage 3 as well, the useful products from fractional distillation, and the trends in properties of hydrocarbons. So we need to link the length of the carbon chain of the hydrocarbon with its properties. So we're going to start off with how crude oil was formed. And if at any point in this presentation you want to pause and make notes, please obviously feel free. It will be a good idea to make sure that you've got answers to the previous slides' questions. So first off, crude oil is a finite resource. That means there's only a certain amount of it. And it's non-renewable because this started to be created millions of years ago. So what happened millions of years ago is that microscopic plants and animals, which we call plankton, they live in the sea, when they die, they would fall down to the bottom of the sea bed. Then over time, you get sedimentation, so you get layers of sand and mud that will start forming layers on top of those dead plankton. With those layers being formed, it creates huge amounts of pressure. And with that pressure will also come high temperatures. And that pressure and high temperature will take those carbon-based life forms, that plankton, and will convert it into what we know as crude oil. Now, to get crude oil, you've probably seen pictures of oil rigs before. You can have rigs on land as well. But what they do is they drill down into the earth, and when they get to an area that contains oil, they'll then extract that oil. So they obtain that oil by drilling. So if you want to pause the PowerPoint and make note of how crude oil was formed, please do so. And then I'm going to move on to the process that we can separate useful stuff from this crude oil. So you should have come across before about fractional distillation. We've done distillation in chemistry, and that's where you are heating a mixture of substances and you're separating them depending on their boiling point. And fractional distillation is just a more complex version of that, because instead of just taking out one thing, you actually take out lots of different things all at once, and they're called fractions. So it's called fractional distillation. As you can see at the bottom, I've put in two really important words that we must use when talking about the process of fractional distillation. Evaporation, or you can use the word vaporization, either one, and condensation or condensing. So what happens is the oil is superheated to about 350 degrees Celsius, and it's piped in to the bottom of the fractional distillation column. Now, when it gets into the fractional distillation column, because it's so hot, a lot of it will evaporate, okay, or vaporize, and it will start moving up the fractional distillation column. Now, because you're putting all the hot stuff at the bottom, it means the hot bit of the the bottom bit of the distillation column is very, very hot, but the top bit of the distillation column is a lot cooler. So you end up with a temperature gradient. So as you go up, the temperature decreases. Now, as those different molecules start going up the distillation column, depending on how long those carbon chains are, they'll start condensing. Okay, so bigger molecules with more carbons on them, they will condense at a lot lower level than the very small molecules that only have a few carbons in, which will go all the way to the top. They have got a higher boiling point. So when they condense, they are kind of tapped off at the different fractions, and you end up with a variety of really useful products. So what I'd like you to do is pause the video now and have a go at naming these different fractions. We've got some pictures here that will help you, but they do have specific names. So pause the video and see if you can remember what the picture is referring to. Okay, so at the top, we have got liquid petroleum gas, okay, or gas. It'll be referred to as both of them, but this is the top fraction, and this tends to be in a gas form at room temperature. These are the things like butane, which we use if you have a gas barbecue, in lighters, things like that. The next one you'll be familiar with is going to be petroleum or petrol, or in America it's referred to as gasoline. Okay, but petrol is what most cars end up using. Now the next one is an important one which we'll talk about later on. It's called naphtha, and this is a really important fraction because actually we use this to make lots of different things that we'll talk about later. The next one, don't know if you know the name for the fuel that aeroplanes use, but it is kerosene. And also we can use paraffin. It comes out at the sort of similar fraction. So kerosene and paraffin will be at this point. Next up is diesel. So some cars, most lorries, buses, things like that will use diesel. So this is another fuel along with the kerosene and the petrol. Next one down is fuel oil. So this can be used in homes. Some homes will use it to heat their homes. It's also used in ships as well. So ships will use fuel oil to power them. Next one, we have got lubricating oils. So these are things that you'll have in your car, you'll put into your car, and also are used in any kind of machinery to reduce the amount of friction. And the last one at the bottom is called bitumen. Bitumen is used to make tar, basically, so we can use it for road surfaces, pavements, and things like that. Now we're going to have a look in the next bit at the boiling points of each of these fractions. So the boiling point at the top is going to be anything that is less than kind of 25 degrees Celsius. So as I say, will be a gas at room temperature. Petrol is 25 to 60 degrees Celsius. So that's why if you ever go to the petrol garage and see people filling up the cars, you often see kind of the wavy vapor from the petrol cap. And that's because it does start turning into a gas. Next one, naphtha, is between 60 and 180 degrees Celsius. And as you go down, you can see that the temperature increases. Now, you do not need to know the boiling point of each of these fractions, but what is important is that at the top is the lowest boiling point, and at the bottom is the highest boiling point. And at each fraction, you've got a kind of range of temperatures for the boiling points. Now I'm going to add on here about the average number of carbons in the chain. So you can see again that at the top you've got very, very small carbon chains. So we only have about 3 carbons, 4, 2, 1, on average about 3 carbons in the chain. So they're much smaller molecules compared to the bottom in bitumen, where you're looking at about 120 carbons all joined together. So as you go up the distillation column, the temperature decreases. So those that have lower boiling points will condense at that point. Whereas as you go down, the temperature increases. So that's why they are the molecules that have got a higher boiling point. Also, something to remember is that the smaller the carbon chain, the lower the boiling point will be. So as I say, you don't need to know the boiling points about all of these. You don't need to know the number of carbons in each chain. But what we do need to know is the trend, okay, or the pattern in the distillation column. So please pause the video and take from that what you need. Okay, so hopefully you've put down about fractional distillation and how that works. Please, as I said before, make sure that we are using words evaporation when something is going from a liquid to a gas, and condensation where something is going from a gas to a liquid. So it starts with evaporation and then they condense at the different fractions. So what we're going to look at now is one important part of the fractional distillation process, and that is one fraction which is called naphtha. Okay, now naphtha is a really useful chemical to get out of crude oil. As you can see from the picture, we use it a lot in chemistry, but you will also have stuff at home that comes from naphtha. Now, we say that naphtha is a feedstock in the petrochemical industry. Now, when we talk about feedstock, it's not talking about food for farmyard animals. It's talking about what goes into it. So different fractions, such as naphtha, is taken by the petrochemical industry and it's converted into different things, or it's used for different things. So I found some pictures on Google Images just to illustrate some of the useful products that we get from naphtha, pretty much all of which you will use at home. So one of the things they use is one of the things that they make from it is solvents. So I've got a picture of a bottle of acetone, but this kind of thing will be in nail varnish remover and some cleaning products that you have at home. Another use of them is lubricants, so things like WD-40, the oil that you put into your car. It just reduces the amount of friction in machinery so that it doesn't get worn down. Another one is polymers, and you're going to look more about that with Miss Slade tomorrow. That's looking at plastics and things like that. So we can use the naphtha fraction and we can actually use it to make plastics, which we use in all of the time in our everyday life. And another thing we can use it for is detergents, and that kind of ties in with the solvents. So detergents are used to remove or clean things, and it's because it will dissolve that stain or that substance that is on something. Right, so we're going to look a little bit more about some of the properties of the fractions. We're always going to refer to the length of the carbon chain. So we've already spoken about boiling points. So here I've got 3 hydrocarbons, which means that it contains only hydrogen and carbon. So these are 3 hydrocarbons, going from the shorter chain on the left to the longer chain on the right. And as you can see, the shorter the chain, the lower the boiling point. So the one on the left has only got 4 carbons, that is butane. That has a boiling point of 0 degrees Celsius. And you can see that as the carbon chain gets longer, the boiling point increases. So the bigger the molecule, the higher the boiling point. We're now going to look at flammability. And flammability is all to do with how easily something sets on fire. Now, if you think of the gases like butane that are used in camping stoves, barbecue, gas barbecues, lighters, things like that, they're very, very easy to set on fire. So they have a high flammability. Whereas if you go to the bottom of the distillation column, like bitumen, if you try to set fire to the road, it's very, very hard to set it alight. So it has a very low flammability. So we can say that the trend is that the shorter the carbon chain, the higher the flammability, or vice versa, the longer the carbon chain, the lower the flammability. The other one that we need to know about is viscosity. And viscosity is all about how thick the substance is. So if something has got a high viscosity, it means that it's thicker. So if you think of the difference between water, which has got a very low viscosity, it's very runny, compared to treacle, golden syrup or honey, that's got a much higher viscosity. So viscosity is all to do with how runny it is or how thick it is. So if we're looking at the trends, we can say that the longer the carbon chain, the higher the viscosity. Or the shorter the carbon chain, the lower the viscosity. So those are the three trends that we need to know about crude oil fractions. Okay, so the fractions we get from crude oil. We need to know the trend in flammability, the trend in boiling points, and the trend in viscosity. So please pause the video now, and if you could put in a sentence for each of those, the trend comparing to the length of the carbon chain. Okay, so I mentioned a couple of times about hydrocarbon. So what we're going to look at now is what a hydrocarbon is. We're going to be looking at one particular group of hydrocarbons called the alkanes. So hydrocarbons are molecules that contain hydrogen and carbon only. So if they give you a molecule that has got a random chlorine or a sulfur added onto it or oxygen, that is not a hydrocarbon. Hydrocarbons only contain carbon and hydrogen. And the vast majority of crude oil is made up of molecules that are hydrocarbons. There are other impurities in there as well, but the vast majority of it are these hydrocarbons. So as you can see from the two pictures, we have got different representations of a molecule. So in the first one, in the top left, you've got methane. That has one carbon and 4 hydrogens. So it has the formula CH4. You've got the carbon in the middle, and then you've got these lines which represent bonds to the white circles on the outside, which are hydrogen. If you've got carbon and hydrogen bonding together, what type of bonding will that be? Will it be ionic? Will it be covalent? Or will it be metallic? Well done if you said covalent. Is a covalent bond because it is between two non-metals. The other picture is a computer representation, and on that you have got 5 carbons, and each of those carbons is joined to hydrogens as well. So, naming hydrocarbons. In the combined science, you only need to know about 2 groups of hydrocarbons, the alkanes and the alkenes. Miss Slade will be talking about the alkenes more next lesson when she's talking about cracking. So we're going to be focusing on the alkanes. Now the alkanes are a very important group of molecules. That is what most of those fractions are going to be made of, is where you've got single bonds joined between the carbon and the hydrogen. Okay, now carbon is in group 4, so it wants to make 4 bonds so that it has a full outer shell to get that magic 8 in the outer shell. So it shares its electron, each carbon will share its electron with 4 other things. So if we've got 1 carbon on its own, it's sharing it with 4 hydrogens. If you add an extra carbon to it, there'll be a bond between the 2 carbons, and then each one will be joined to 3. So if you're ever drawing these, if you're ever asked to draw an alkane, please make sure that you have got 4 lines coming out of each of your carbons, because it wants to make 4 bonds. Now, we can work out, we can predict how many hydrogens there will be if we know how many carbons there are on a chain. You might be asked to draw them, in which case these are the first 3 hydrocarbons, these first 3 alkanes. We've got methane, ethane for 2 carbons, and propane for 3 carbons. But if it asks you to say how many hydrogens there are, you just need to take the number of carbons, times it by 2, and then add 2. So we end up with the general formula CnH2n plus 2. So whatever n is for carbon, to work out the number of hydrogens, times it by 2 and add 2. So if we look at the middle one, ethane, you can see that there are 2 carbons there. So if I times 2 by 2, I make 4, add 2 is 6, and if I count up those hydrogens, that is correct. There are 6 hydrogens. For propane, the one with 3 carbons, again, if there are 3 carbons, I'm going to times it by 2 to get 6, add 2, 8. If I count up those hydrogens, it does make 8. Now you need to know the names and be able to draw the first 4 alkanes. So if there is 1 carbon, as I said, that is methane. Okay, all the alkanes end in ane, so methane. If there are 2 carbons, then it is called ethane. Eth means 2, ethane. And if there are 3 carbons, then it is propane, prop meaning 3. And you can see the formula for each of those hydrocarbons underneath. Now the 4th one is butane. So you can have a go at drawing butane yourselves. It's got 4 carbons, and using the general formula, you should be able to work out how many hydrogens are on it. So draw it and see whether you are correct. So pause the video and have a go at drawing butane. Okay, so hopefully we've had a go at doing butane. You should have 4 carbons joined together, and then going around the outside, you're going to end up with 10 hydrogens. Now, because these are single bonds, we say that alkanes are saturated. Okay, and that's an important term because that is different to alkenes, which are unsaturated. And what saturated means is that you can't get anything more onto the molecule. So in alkenes, you'll have something called a double bond where you could fit on another hydrogen. But these we refer to as saturated. They only have single bonds. So I've got a table here that is showing you some different representations of the first 4 alkanes. Okay, so you've got methane, ethane, propane, butane. You need to remember those names for the first 4. You can check the previous task of doing the butane, because now I've got butane on here, so you've got the 4 carbons and the 10 hydrogens going around the outside. On the final column on the right hand side is just a different representation, and it's showing the bonds and which way the hydrogens are pointing. Now you don't need to be able to draw those, so don't panic. You need to be able to do the ones with the lines in the middle column, but just be aware there is another way in which we can show the molecules. The black circle is the carbon, and then the white spheres are the hydrogens. Okay, so that is what we need to know about crude oil and fractional distillation. So I've gone back to the initial slide where I picked out the 6 things we need to know from the specification, and we're going to run through, check your notes that you have got information about these 6 points. So the first thing we need to know is how crude oil is formed. So we need to know that it comes from plankton, which are those microscopic plants and animals. They go, when they die, go to the sea floor. Then you get layers of sediment on top of it, which creates heat and pressure, converting it to oil. The next thing we need to know is what crude oil is made up of. And the easiest thing to talk about, if you're asked this, is that it is a mixture, because they're not, all those molecules aren't bonded together, it is a mixture of mostly hydrocarbons. And hydrocarbons are molecules that contain hydrogen and carbon only. What an alkane is, and the general formula. So an alkane is a saturated hydrocarbon. So it's carbon and hydrogen with only single bonds. And the general formula is CnH2n plus 2. We need to know the process of fractional distillation. So we need to know that as the heated up crude oil goes into the bottom, it is vaporized or it evaporates, travels up the distillation column, and depending on its boiling point, will condense at different points. We need to know useful products from fractional distillation. So there's the obvious ones about petrol and diesel, kerosene, but also that we can use the fractions to make other things, that they're the feedstock of the petrochemical industry, where we can make solvents and plastics and detergents and lubricants. And the final thing that we need to know is the trends in properties of the hydrocarbons. So we need to know that as the hydrocarbon chain increases, the boiling point increases, the flammability decreases, and viscosity increases. So make sure that you've got notes on all of those things. That is what they will ask you about in the exam. So tomorrow you have got a lesson with Miss Slade, who is going to look at how we can make useful products such as plastic, and also the reaction of combustion. So thank you very much for taking part. Well done. Take care of yourselves, and I will see most of you on Monday. Thank you very much. Goodbye.